Hey class, Dr. Yeager here, going to begin our discussion of desert landscapes today. Obviously, this goes along with your reading for Chapter 14 in your Blue Book and the assigned reading on Canvas on desert landforms. So Chapter 14 in your book isn't about deserts per se, it's about aeolian processes and glacial processes. So we're going to talk about deserts. You can read about glacial processes in your book, and you should do so. But we're not going to talk much about glacial processes, mainly because you will not see any evidence of glacial processes here in Texas. You would have to go to the north to see any evidence of glaciers in the past. No evidence of that down here in Texas. But we will talk about deserts, and as we do so, we will be talking about aeolian processes, which is what your book talks about in chapter 14. So we're going to tie those two things together, and that's a logical thing to do because as we're going to see, aeolian processes, which are processes that are accomplished by the wind, those are processes that are most easy to see in deserts. Um, Deserts are different from the other landscapes that we've talked about. More humid and more precipitous landscapes. They are what we would refer to as abrupt and stark, meaning they have more sharp edges. You are far more likely to see a 90-degree angle on rocks in the desert than you are in a place where it rains a lot. Um, deserts just look different. Deserts are some of the only places really on the planet where you can see a lot of bedrock, that actual exposed crust at the surface. Um, in San Antonio, in the city, you would have a very hard time actually finding bedrock, finding the crust. Now, if you went up into the hill country, that would be easier to do, but down in San Antonio itself, you'd have a really hard time finding finding any of the Earth's crust that's exposed at the surface. Where if you went out to the desert, you would actually see that a lot. And you would see that you'd be able to find that bedrock because there's very little soil in the desert, even in places where the bedrock isn't exposed. It may be only covered up by a very small amount of soil. Regolith is also something that is um, uh, missing in a lot of desert environments. Remember that regolith is that sort of bedrock that is in the process of breaking down into soil, but it's not soil yet. It's partially broken down bedrock um, that has not completely turned into soil yet. So if there's not much soil and not much regolith, that means that we can see lots and lots of bedrock. At the surface, which is unique to deserts. And because there's very little soil, there necessarily will be very little soil creep in terms of mass wasting, and that makes sense. You can't have soil creep. Oh, excuse me, my kids kept me up late last night and then got up early this morning, so it was fantastic. There's very little soil creep in a place, but where there's very little soil, and also there's very little precipitation in most deserts. And remember that soil creep requires some moisture to function efficiently. Because there's very little precipitation in deserts, there also tends to be less chemical weathering. So the predominant type of weathering that we see is mechanical weathering. And like I said before, it's not uncommon to see sharp edges on things. It's not uncommon to see 90-degree angles on rocks across the landscape in deserts. That's because in places where there is um, less precipitation, remember, partially the effects of water as a weathering agent are to wear down sharp edges. Remember in our discussion of alluvium, how alluvium, due to the effects of running water, um, ends up being smooth on all sides. Well, where there's less precipitation, where there's less water, as a weathering agent, you're going to see fewer. You're going to see less of that effect, and so a lot of the rocks that you see in deserts and dry areas tend to be sharp on sharp on the sides, particularly more so than in places where there's lots of rain. Deserts are also unique because they have lots of what we call impermeable surfaces. Impermeable surfaces are surfaces that things cannot pass through. Okay, so if you think about you're in an art class and you want to build or you want to create like a bowl or a pot or something, what do? Well, you get clay and you fashion the clay into whatever shape you want it to be, and then you take the clay and you glaze it and whatever, and then you put it in the kiln, and the kiln exposes it to high temperatures and dries it out, and then when it's all said and done, you can put water in the clay pot, and the water will not simply go through it. Clay is a great substance for making bowls and pots out of because the particles are really, really small. And when the particles bind together, there's very little space in between the particles. And so when we take clay and we let when we let the clay particles bind together and then we fire it in the kiln or we expose it to high temperature, it makes for a surface that is impermeable. Water can't get through it. Much of the soil that exists in many deserts is clay in nature, and that means that any space that exists in between the particles is very, very small, and it's difficult for water to permeate down into the soil after it rains. As such, whenever it rains, water doesn't infiltrate down into the ground, it just runs off. Okay, we call that hardened soil a hard pan. It's very difficult for water to infiltrate um, down into the soil in places where you have those hard pans. Another type of impermeable surface that exists in the desert is what's called a cap rock. Cap rocks are things that you would see in places where you have an uplifted piece of bedrock, and by looking at it, you can tell that it's sedimentary in nature, meaning that it has horizontal strata of rock that you can see, and the different kinds of rock underneath the cap rock, which is the rock on top. And these different types of rock, some are softer than others, some are harder than others. And the softer ones obviously are subject to weathering and erosion much more so than the hard ones. Well, the soft rocks erode very, very quickly. And at one point there may have been different rocks on top of that cap rock. That cap rock is a type of rock that is resistant to erosion. It's impermeable, meaning that when water falls on it, it can't infiltrate down into the rock and weather it away. So when you see things like mesas and buttes and spires, some of these desert landforms that you may be familiar with, if not, we'll talk about them later on. When you see these types of rocks, these cap rocks there, often the last sedimentary layer of rock to weather or erode on a mesa or a butte. And as cap rocks, they often sit up at the top. They're the flat layer of rock up at the top. So because deserts have all these impermeable surfaces, whenever it does rain, it may only rain once or twice a year, but whenever it does, very little of that water penetrates down into where it falls upon. So it all moves down the slope with overland flow. And as such, whenever it rains, that runoff event can happen very quickly and it can happen very severely. In terms of flash floods, where you hear about flash floods happening and being dangerous for people, tend to be in desert areas. We don't really oftentimes hear about flash floods in places that get a lot of precipitation, or that don't have impermeable surfaces because a lot of the water infiltrates down into the ground. And so overland flow isn't as severe in deserts because overland flow is the predominant occurrence after it rains. Um, that that great quantity of water that rushes into the streams and rushes downhill with gravity can happen very, very quickly and can be really, really dangerous. And that brings us to an important point. Even though we talk about deserts in the chapter on aeolian or wind weathering and wind erosion, weathering when it comes to wind versus water, water is such a strong factor, or such a strong agent of erosion, so much stronger than wind, that even in places really, really dry deserts where maybe it only rains once or twice a year, let's say you have a desert where it only rains once a year, the weathering and erosion that happens in that desert on that one day is going to be greater than all of the wind, weathering, and erosion that happens on the other 364 days put together. Even in the driest desert, okay, when it rains, that's when almost all of the weathering and erosion happens. Fluvial erosion is exponentially more powerful than wind erosion. Okay, so make sure you are aware of that. We seem to want to think about wind erosion being most dominant in deserts, but even in deserts, fluvial erosion is still the most powerful agent of erosion. I guarantee you I will ask you that on the upcoming test, and some people will miss it. So don't be one of those people, okay? Another important thing that we see in desert areas is what we call a basin of interior drainage. And basins of interior drainage are exactly what they sound like. They are a basin, meaning they're sort of a bowl, a low area surrounded by high areas. And in this basin, things drain to the interior, meaning all of the watersheds lead down into the basin where there is no place for them to escape to. So water doesn't get to sea level in a watershed with a basin of interior drainage. If you look at the Great Basin out in the American Southwest, it is a large basin of interior drainage with about a dozen watersheds, all of which drain to low points inside the Great Basin. One of the watersheds is the Great Salt Lake. The Great Salt Lake watershed, and for the Great Salt Lake, streams from the Wasatch Mountains and the Bear Mountains drain to the south and to the west, and they terminate into the Great Salt Lake. And a lot of the lakes, be they permanent like the Great Salt Lake, or be they sort of temporary lakes that only fill up after there's a rainstorm, a lot of these low points in the Great Basin or in any basin of interior drainage tend to be salty lakes. And why they're salty is because all water has salt in it. The water that comes out of the water fountain, the water in your water bottle, or the water in the Great Salt Lake, the ocean, it all has salt in it. So even these mountain streams that come down and they flow into one of these low lakes in the Great Basin, they fill up the basin after it rains. And if there's not very much rain, that water will eventually evaporate, right? And so the water that evaporates, the H2O evaporates, that turns into gas. But anything that's in the water, be it pollutants or be it salt or whatever, that stuff can't evaporate, and so that stuff is left behind. So in a lot of these areas of interior drainage, you'll have these low points and valleys that fill up with water every time it rains, but most of the time they don't have any water in them. A lot of times those valleys will end up being covered up with a layer of salt from all of the water that has evaporated from every time it rains. Okay, we will pause there and we will pick it back up in our next video. So we will see you there.